In this video, we're going to talk about grout for structural masonry walls. The masonry assembly is going to be made up of block, mortar, and grout. All of those elements together are going to be denoted with a strength of F'(M). In this video though, we're going to focus just on grout. Grout has to be at least 2000 psi or stronger. The strength of the grout also has to be greater than the overall assembly strength. Grout is essentially fluid concrete. It's going to be there to fill the cores of masonry. It's going to be the element that's going to create that internal moment arm for reinforced masonry between the reinforcement, which is going to be a tensile element, and the compression element, which is generally going to be governed by the masonry face shells. But grout is going to be the element that's going to be bringing those elements together to create some sort of moment capacity, strength capacity for the masonry wall. It's going to be composed of a mixture of water, cement, sand, pea gravel. Grout's going to be either fine, coarse, or self-consolidated grout. And the biggest thing that I want to point out here is grout is not the same as mortar. It has very different properties, and it's going to be used for very different purposes within a masonry wall. From other videos, we talk about the strength of the assembly, F'(M), how we come up with that strength of the assembly. The really important part here is to know that grout is not one of those elements that is going to be used to determine what the assembly strength is. The assembly strength is going to be based on the strength of the units, the type of mortar that we used. From that, we're going to get our assembly strength. Once we know what our assembly strength is, again, the grout has to be at least as strong as the assembly strength, determined by units and mortar, and it has to be at least 2000 psi. Grout options that we have, if we have something that's going to be a heavily reinforced masonry system, we maybe want to consider fine grout. If we have very little space between reinforcement and face shells or webs of masonry, it's a good time to use fine grout. Coarse grout could be used in a lightly reinforced masonry wall where we have a lot of cavity space for coarse grout with larger aggregates to flow between those different elements. Of course, we also have self-consolidated grout, and we'll talk about maybe when we want to use that. First, we'll talk a little bit more about some more grout options. We have pours and lifts. A grout pour is going to be the total height of masonry to be grouted prior to the erection of additional masonry. So a grout pour can consist of one or more grout lifts. A grout lift is going to be the increment of the grout height within a total pour, and it's going to consist of one or more grout lifts. So there's going to be a maximum pour height, maximum lift height that we have to consider for the construction of masonry walls. So again, something like a 5'4" grout lift could occur multiple times within an overall wall height that can be the total grout pour. Options that you have is you can have a larger grout lift if we add cleanouts to the masonry wall, and we can even have a larger lift to the full pour height up to 24 feet if we use self-consolidating grout. And again, self-consolidating grout is going to be a very fluid grout that can be able to flow within the masonry wall very freely. On the project notes, again, we want to define properties for each of the different elements that are going to be making up a masonry wall. Grout F'(G) is going to be something that's going to be determined based on what the block strength and mortar type give us in terms of an overall assembly strength, and then we can specify the grout strength to be at least that strength or greater. Everything in this video is going to be discussed within the paper that you can download from this website. And that's going to be it for today. I look forward to talking to you on future videos.